Okay, today we're going to be talking about ellipses, and we're going to start off with a basic understanding of what all these letters mean. Well, let's first start with the center. The center is going to be HK, and the longer axis is going to be what's called the major axis. That's going to be the longer axis, and so we'll put longer. And the minor axis is going to be, so why don't we say in blue, I'll give you the major axis. That's your major axis. In green, it's going to be this. This is going to be your minor axis. So your minor axis is going to be your shorter axis. Now, depending upon how the ellipse is drawn, if we have, let's say we have an ellipse that looks like this, and now this would be an ellipse that would be maybe a lot bigger in the y direction than it is in the x direction, then your major axis, this would be your major axis right there, and this would be your minor axis right there. Okay, so for the major axis, the distance from the vertex to the, from the center, to the vertex is going to be letter A. So that's going to be the distance A. And the distance from the center to the co-vertice is going to be a distance of B. And the distance from the center to the focus is going to be a distance of C. I know things are getting a little jumbled here, but essentially it's different from a parabola. Parabola, we were focusing on the distance from the vertex to the focus. Now it is the distance from the center to the focus, and that distance is C. All right? And so we have the major axis, we have the minor axis, we have the vertices, and so the Pythagorean theorem, or should I say the Pythagorean relation, is going to give you the ability to find C, which once again is the distance from the center of the ellipse to the focus point, either right and left or up or down. Let's also make some other notes. The foci will always be on the major axis. The foci will always be on the major axis. Let's put that there. The vertices will always be located on the major axis or the longer axis. The minor axis will have co-vertices, but we really don't see those too often. But if you're ever asked for the co-vertices, then those would be the ones located on the minor axis or the shorter axis. All right? And once again, A is always going to be bigger than B. And so if A is underneath the Y, then that's going to create a longer ellipse. If the A is underneath the X, then that's going to create a wider ellipse. So let's see how this works in some problems. Okay, example 1, it says find the vertices and the foci of the ellipse 4x squared plus 9y squared equals 36. I want you to notice here that the equation for an ellipse, you've got to get it equal to 1 first. So that's your first step, is you got to get this equation that they give you equal to 1. And so all you do is simply divide. If it's not already equal to 1, you just divide by the constant that's on that side. And then you're going to reduce the fractions. So 4 over 36 goes in there 1 out of 9 times. So x squared over 9. And then 9 over 36 reduces to 1/4. And then 36 over 36 is 1. So we can identify that the bigger number is underneath the letter x. So that means this is going to be a wider parabola, and so let's just see if we can sketch this out. So this ellipse is going to be centered at the origin, and it's going to be longer in the x direction because the 9, which is the bigger number, is underneath the x. And so if we count off, that's going to be, this is a squared, so that means a is 3 and b is 2 because these are squared values. So if we go 1, 2, 3, that's going to be the first vertex, and then we'll go left 1, left 2, and left 3, and that's going to be the other vertex. So those are the vertices, and now we need to get the foci. And the foci, as we said, are going to be located a distance of c from the center. Center is 0, 0. And so we're going to use this equation right here to find c. So a squared is 9, b squared is 4, plus c squared. And you can solve for c. It's going to be the square root of 5. So that means that the distance from the center is going to be root 5. So there's going to be a foci, right, let's see, root 5 is about 2.2. So maybe in red we'll put the foci. So there's going to be a foci right there and a foci focus right there. So it's going to have coordinates of root 5, 0. And then the other one is going to be negative root 5, comma, 0. Okay, in example 2 it says find an equation of the ellipse with a foci of 0, negative 3 and 0, 3. And so let's draw our x and y axis. So we'll draw our y axis and our x axis, and then on there we will put our foci. And so 0, negative 3, so that's going to be down here. And then 0, 3 is going to be up there. And it has a shorter axis. Now remember, the foci are always located on the longer axis on the major axis. So the shorter axis has a length of 4, which means from the center it is going to be 2 to the right and 2 to the left. So we will go 2 to the right and put a point, and 2 to the left and put a point. And so now we can, let's see if we can get our ellipse just right. That's good enough. So there's our ellipse, and we've sketched it, and now we want to find an equation for this ellipse. All right, so it's going to be, it's centered at the origin, so it's going to be x squared over. In the x direction, we're going 2 units to the right and 2 units to the left, so that's going to be 4. And now, in the y direction, excuse me, actually I made a mistake, so let me go back and fix that. These are the foci, and they are not the vertices, so excuse me there. Let's go back and fix that. The vertices are going to be located above, somewhere above and below these foci. And so therefore the ellipse is going to look something like that. So these are the foci and these are the vertices. So we'll say vertices right there. So we know that our B is 2 because that is the half of the shorter axis. That's B. We know our C is 3, and so that's going to be the distance from the center to the focus. And so we can use this equation right here. So A squared is going to equal B squared, which is 4, plus C squared, which is 9, and that's going to be 13. And so now we are going to put that underneath the y variable because this is longer in the y direction than it is in the x direction. So we will say y squared over 13 plus x squared over b squared, which is 4, equals 1. And that is our equation of the ellipse. All right, example 3, it says find the standard form of an equation for the ellipse whose major axis, the longer axis, has endpoints -2, -1, and -8, -1. So once again, let's draw our x-axis, let's draw our y-axis, and let's put our endpoints on there. So our endpoints are going to be at -2, -1, so that's going to be left 2 and down 1. So there's one of the endpoints of the longer axis. And then 1, 2, 3, 4, 5, 6, 7, 8, -1. So from -2 to +8 is a length of 10. So the major axis has a length of 10. All right, so that means from the center is going to be a length of 5. So let's count. 1, 2, 3, 4, 5. So now we know that the center is going to be 3, -1. And we know that A is going to be 5. And it says that the minor axis has a length of 8, which means it's going to be 4 up and 4 down. So let's go ahead and put that there. So that's going to be 1, 2, 3, 4. So that's going to be there. And then 1, 2, 3, 4. That's going to be there. And so if we make our ellipse, not a very good ellipse at all, but you get the point. And so it wants us to find the equation for this. So our equation is going to be, well, it's longer in the x direction, so we need to put the bigger number underneath the x. And now we have to account for the center. So it's going to be x minus 3 squared over a squared, which is 25, plus y plus 1 squared over 16, because it's 4 up and 4 down, and that's going to equal 1, and that is your equation for this particular ellipse. All right, find the center, vertices, and foci of the ellipse. Okay, so now once again we want to draw our x and y axis. There's our y axis. Here is our x axis. And now we want to, first of all, identify the center. That's pretty simple. That's just going to be -2 and 5. So let's write that in there. Center will be -2 and 5. So let's draw that. Left 2, 1, 2, 3, 4, 5. And there is our center. Now, to get the vertices, once again, the vertices are located on the longer axis. So we see that if we take the square root of that, that's going to be A equals 7 and B equals 3. So that means we need to go up 7, running out of space here. We go up 7 and down 7. That will give us our vertices. Well, let's just see. This has coordinates of -2, 5. If we go directly up 7, that's going to give us -2, 12. And if we go down 7, that's going to give us -2, -2. So now we have the vertices, we have the center, and now we need to get the foci. All right, the shorter axis is going to be 3 right and left from the center. So that's going to be over here, and that's going to be right there. So let's go ahead and draw our ellipse. Ooh, once again, I'm a horrible artist, but you got the idea. Now the foci are going to always be on the longer axis, the major axis, a distance of c from the center. So let's go ahead and use this equation right here. So a squared is 49 equals b squared, which is 9, plus c squared. So c will equal the square root of 40. And so that is going to be the distance from the center. So we need to go root 40 down and root 40 up. Now pay attention that when we studied parabolas, we were focusing on the distance between the vertex and the foci. Here we're not focusing on that length, we're focusing on the distance from the center to the foci. So the foci are going to be located at -2, 5 plus root 40. And then the other one will be at -2, 5 minus root 40. And those will be the two foci. Okay, this last example is quite simple. It says write the equation of a circle. And we remember that the basic equation of a circle is x minus h squared plus y minus k squared equals r squared. Well, we know the center is -2, 5, so it's going to be x plus 2 squared plus y minus 5 squared equals r squared. Well, the radius is root 3. Square that, that is going to be 3. And there is your equation for a circle with a center of -2, 5 and a radius of root 3.